All right, suppose we're solving on the interval from 0 to 2 pi. Let me write that a little better. From 0 to 2 pi. Give the exact solution in radians and give an approximate solution in degrees rather than one decimal place. All right, here's my equation. I want to solve. To solve this, I'm going to say sine of x is equal to 1/6. I'm going to divide both sides by 6. All right, now, if I try to find an x value, where's my sine of x equal to 1/6? Well, that was not one of those values I had to learn on the unit circle. In fact, it's not a pretty value of x that you'll get out of that, okay? So what we do in this case, if we get a value like this that's not on the unit circle, is we say, okay, x is equal to the angle whose sine is 1/6, or we use the inverse sign here. X is the angle that whenever I take the sine, I get 1/6, right? Let me repeat that. X is the angle whenever I take the sine is 1/6. Or I could say x is the angle whose sine is 1/6. X is the angle whose sine is 1/6. Let's think about that for a second. If I think about the unit circle, here's my unit circle, and the angle whose sine is 1/6. Wouldn't that be an angle in quadrant 1 if it's a positive 1/6? If the sine of it's a positive 1/6? So here's that angle whose sine is 1/6. Or I could say this angle is the inverse sine of 1/6. And the reason why I write it that way is because I don't have a pretty value that calculates out of this, okay? So I write it that ugly way, inverse sine of 1/6. So that's one of my answers. X is equal to the inverse sine of 1/6. Where else do I have an angle? Whenever I take the sine of it, I get a positive. Well, that would be over here in quadrant number 2, right? And what is this reference angle? This reference angle is going to be the same displacement as this angle right here. So it's going to be what? It's going to also be the inverse sine of 1/6 at reference angle. So what's the second angle I get out of this? The second angle I get out of this is this angle right here. And how do I find that angle? That angle is going to be pi back off this much, or pi minus that much. Or I could say pi minus that much is what? The inverse sine of 1/6. All right, so that's my radian values right there. They're not pretty, but that's exact, okay? So it wants me to solve on that interval, give the exact solution in radians. So I'm going to say in radians. My exact solution from 0 to 2 pi is going to be, now let me write solution set notation like they do. The inverse sine of 1/6, and this one, pi minus the inverse sine of 1/6. All right, now what about in degrees? What about in degrees? Well, that's whenever it becomes calculator time here. So we'll get out our calculator and we're going to enter some stuff here, okay? Now for the calculator, what do I need to make sure of with the calculator? I need to make sure I'm in degree mode. So I'm going to hit mode. I'm going to scroll down to degree if I can get this thing focused. Hit enter. Now let's get out of there. All right, so I want to enter the inverse sine of 1/6. So how do I do that in the calculator? I hit second function, the sine, and 1 divided by 6. Close my parentheses, hit enter, and you get that number. Kind of hard to see, but I'm going to write it down over here. So in degrees, I'm getting x is approximately, whenever I put this in a calculator, I got 9.6 degrees. And how about this angle right here? If I'm looking at degrees, what do I need instead of pi minus inverse sine of 1/6? I need 180, right? Because think about it. If we're looking at degrees now, we're 180 degrees here. So this blue angle right here is going to be 180 back off inverse sine of 1/6. So let's put in 180 minus the inverse sine of 1/6. And what do we get? We get about 170.4 degrees. So let me list it in set notation. I'm going to say in degrees, the answer is going to be 9.6 degrees, 9.6 degrees, and 170.4 degrees, rounded to one decimal place. There we go.